Alrighty folks, today we're on 11.4 surface area of pyramids on page 304 in the Green Book. We're going to draw and use nets to find the surface area of a rectangular pyramid or a triangular pyramid. Use formulas to find the surface area of a rectangular or triangular pyramid. Then rename surface area units in equivalent forms. So, parts of a pyramid with lateral faces, bases, and slant height. So right here, this little rectangle here is our base. Okay, so this is a rectangular pyramid because the base is a shape of a rectangle. Your lateral faces, I'm going to do here in yellow. This is an example of a lateral face. Okay, the slant height here in red is the length of the height of each lateral face. Okay? Alrighty, so let's talk about the formula. The surface area of a pyramid. Okay, that equals the area of the base plus the lateral area. So right here is a tetrahedron, which is a triangular pyramid. Okay, and we're going to do this one using the dimensions here. Okay, so in a tetrahedron, all of the lateral faces are congruent isosceles triangles. The base is an equilateral triangle. So all of these are the same, and then all of these are the same. Okay, so keep that in mind. All right. So let's do this. So to find the height of the equilateral triangle base, we're going to use the Pythagorean theorem. Okay? Because right here, all right, so each of these that I just outlined right here are 6 centimeters. Okay? I want to find out what this blue dotted line is. Okay? So this is a right triangle. So it's like if we put it over here. So this is the dotted line that we need. And we have these right here. Okay? So we're trying to find out what our dotted line is. We don't know what that's going to be, but we know that our slanted line right here is 6 centimeters. And this line right here is 6 as well. But where this right triangle cuts it off, it's going to be half and half. So it's going to be 3 and 3. So this right here is 3, but we're looking for that. So we're going to use the Pythagorean theorem to solve this bad boy. Okay? So, remember, this is our hypotenuse, or this is c squared. This is a squared, and this is b squared. Okay? So we're going to have 3 squared plus b squared equals c squared, which is 6 squared. Alrighty? So, what I'm going to do is I'm going to try and solve for c. Okay? So, I'm sorry, for b. So this is going to be 9 plus, I'm going to cross this out, that's 9, that's 36. Okay? So I'm going to get all these on the same side, so that it says b squared equals, so I'm going to do subtract 9, so then we have b squared equals 27. Okay? I'm going to square root both sides to get b equals. So b equals, now the square root of 27 is going to be an irrational number, so I'm going to do it for you. It simplifies down to 3 square root 3. Okay, so that's your answer. Okay, so this length right here for the height is going to be 3 square root of 3. But that's only when you have a missing dimension. Okay, so let's do one with a rectangular one. So right here, let's do one with, let's do the net. So we're going to do a rectangle. Whoa, that's terrible. Okay, so right here, it's going to be 12 centimeters. The height for here is going to be 10 centimeters. And the height for here, for this triangle, is going to be 17 centimeters. Okay, so in order to find the area of this pyramid, let's do the area of the rectangular base first. Okay, oh, sorry, and then down here, it's going to be 30. So let's do the area of the base first. which is length times width, so it's going to be 12 times 30. It's going to be 360. So the area of these red triangles, which is 1/2 times base times height. That's 1/2 times 12 times 17. Okay, that's going to be 102. Now the area of the yellow triangles, it's going to be 1/2 times 10 times 12. Nope. I'm so sorry. 30 times 12. It's going to be 150. Okay? To end this bad boy, let's do this. Let's do the sum of the areas of the lateral faces. So we have 2 of the red triangles, and we have 2 of the yellow triangles. So we're going to multiply those together, and we're going to add these 2 together. So that's going to give us 504. We need to add that to our area of the base, which was 360. So we have 360 plus 504, which is going to be 864 centimeters squared. Okay, so again, that's kind of the easiest way to do it. I would do it that way if I were you. I'm only going to do these few examples just to keep it a short video. What I would like you to do, though, is to take notes on converting dimensions. There's just 2 examples where it says convert each dimension from centimeters to millimeters, and then calculate the surface area, find the lateral area. So copy those 2 examples down in your notes, and I will see you in class. Okay. Adios, amigos.